Alright, so we're going to start looking at the topic of algebraic fractions. There's some questions that I've uploaded onto the Google Classroom. What I'm going to try and do in this video is just talk you through a few examples of how to try and think about doing the questions that will hopefully enable you to try some of the questions where they're not maybe as straightforward as they start off. So this is the first example I want to look at. The important thing to remember with algebraic fractions as a topic, not just simplifying them, not just adding them, anything we do with algebraic fractions is they are the same as numerical fractions. They work in this, obviously not the same in that they have algebraic terms in them, but they work in exactly the same way. They don't follow different rules, they follow exactly the same rules as any other fractions. So when I'm looking to simplify algebraic fractions, what I'm looking to do is find factors from a numerator and denominator and cancel that down. Sometimes I think it ends up with us doing things for algebraic fractions because we think, oh, I can do this with a numerical fraction where we can't. For that reason, I'm just going to demonstrate with one example of a numerical fraction simplifying it. So if we look, for example, at the fraction 12 over 18, you could probably quite quickly tell me that is the same as 2/3, and you just write that's equal to 2/3. I want you to think about the middle step that we put in that, and that middle step is pulling out a common factor from the numerator and denominator, that common factor here being 2. So we could write 12 as 6 times 2 and 18 as 6 times 3. Okay, and then that is what allows us to write the answer as 2/3 because we can say, well, I can divide this whole numerator by 6. I can divide this whole denominator by 6. That is the approach that we're going to be taking here. Okay, and the reason why it's worth pointing that out is because we're so confident with our use of numbers that we can do that approach quite easily without writing out any of those middle steps with numerical fractions. That's not always going to be the case with algebraic fractions. So, in this example, what I'm looking for is, what do I have in common? Well, I've got 24 as a number on my numerator and 6 on my denominator. So, they both have 6 in common. So I think I can make that 6 a common factor. Okay, and then if I consider what I'm multiplying by on the numerator, I need a 4 to make 24. Right? 6 times 4 gives me 24. I've got an a on my numerator, no a on my denominator, so I can't take that a out as a common factor. On my numerator, I've got a b, on my denominator, a b cubed. So I can take out just one b. I can't take out b squared because I've not got enough b's on my numerator. So I can have a b on my numerator and denominator. But then I also need b squared in here because my denominator needs to have b cubed. So b times b squared gives me that b cubed. And finally for the c's, I've got a c squared on my numerator and a c on my denominator. So I can take out one lot of c. I don't need any more c's in my denominator, but my numerator, to get c squared, needs an extra c. So I've got 6bc times 4ac divided by 6bc times b squared. Okay, and because I'm multiplying those things, I can divide my numerator by 6bc and just have 4ac left, and I can divide my denominator by 6bc as well and just have b squared left. Okay, so what I'm essentially doing there is dividing this numerator by 6bc and dividing my denominator by 6bc. In the same way, we divided them both the numerator and denominator here, by 6. Okay, and that's how we'd simplify that type of algebraic fraction. Okay, a very similar example, but just one thing to be aware of first, that sometimes you might need to simplify your numerator or denominator on its own first before you cancel out. So here we've got 18xy squared over 15, and then this xy being in brackets might sometimes lead us just to apply this squared to one or the other. This question is going to going to look a lot easier if I think, well, xy times xy is x squared times y squared, because I've got x, y times xy, 2x's being multiplied is x squared, the 2y's being multiplied is y squared. And now I can take the same approach as I had before. That bracket before with the squared around it was sort of stopping me from doing that. So look at 18 and 15. They have 3 as a common factor. Let's draw my vinculum, my fraction line, and put my multiplication in. So 3 times 6 would give me 18. 3 times 5 would give me 15. Now I can look at my x's. I've got an x and an x squared, so I can take an x out from both of those. And that just leaves me needing an x on my denominator. So I want that to be x squared. I've already got the only x I need on my numerator. On my numerator and denominator, I've got a y squared for both of those. So I can take out y squared in both of those cases for the numerator and denominator. It's a common factor. So now I can divide my numerator by 3xy squared and just have 6, and divide my denominator by 3xy squared and just have 5x, and I've got my simplified expression. Okay, it doesn't even have any y's in it, just 6 over 5x. Okay, this question's a little bit different now, because instead of just having things that I'm multiplying on my numerator and denominator, I've now got things that I'm adding as well. Okay, and this is where we go back to that example before with a numerical fraction. Sometimes people just want to sort of cancel out parts of this. We can't do that as easily here. Okay, there's a mistake in this question. Let's write that as a 3 instead. Okay, so let's pretend this question wasn't written the way it is. So it should be 3a plus 15 over 9. Okay, I might explain after I've done this why that was a typing mistake. So we're going to try and simplify this. Okay, as I was saying before, sometimes some people just like to think, oh, I could cancel this out. I could divide this by 3 and that by 3, this 15 and this 9. We can't do that because we need to divide the whole of the numerator or the whole of the denominator by the common factor. So what I need to try and do first here is take out a factor here. So I can factorize this into 3 lots of a plus 5. Now you might be seeing why I got you to do some of the practice on different tasks that we did earlier in the week. This denominator 9 is 3 times 3. So I can divide the numerator by 3 and just have a plus 5. The denominator by 3 and just be left with the other 3. So it's a plus 5 over 3. I've essentially divided the numerator and denominator by 3. 3a divided by 3 is a, 15 divided by 3 is 5. I couldn't just divide one of these terms. They both need to be divided by 3, which is why this step of factorizing it, writing it with a bracket, is really useful. The reason why 5a wouldn't have worked, so just sometimes you might get given expressions that you might want to try and simplify that you can't. If I tried to factorize that expression, I would have got this. And 5 and 9 don't have any common factors, so I can't cancel that down. 9 also doesn't have any common factors with a plus 3. Okay, this looks probably a lot more complicated, but it's not. It's exactly the same idea. So I'm going to go into focus first on factorizing my numerator. 12 and 15, they have a common factor of 3. X squared and x, I can get x out of both of those, and I can take a y out of both of those. And now putting into brackets, okay, 3 times 4 is 12, x times x is x squared. I've already got a y, I don't need to add another one in there. 3 times 5 gives me that 15. I've already got my x and y, so I don't need any of the letter terms in there. And we're dividing that by 3x squared. Okay, and now I want to see what can I cancel down. Well, I can divide the numerator and denominator by 3. Okay, and I can do that because I'm multiplying the whole of this numerator by 3 and the whole of the denominator by 3. It's not something that I'm adding or subtracting to something else. I've got an x here and I've got an x on my denominator. but I can't cancel down the x squared, I can just cancel down one of the x's. So let's actually just write that as an extra step, just in case it confuses anyone if I did it in one step. So instead of thinking as this as x squared, I'm going to think of it as x times x. So I can divide the numerator by x and the denominator by x. Again, those x's I'm multiplying by the rest of the numerator or the rest of the denominator, not adding or subtracting. So now I've got y over 4x plus 5 over x, and that's as simplified as I can make that. So I could have just gone from this step here to this step here by thinking x over x squared. Well, if I have divide by x on the top, I'd get rid of that x. If I divide by x on the denominator, x squared divided by x would just leave me with this x. Okay, we've got, let's check, 2 more examples to look at, okay, so not too much longer to go. And here I've got some things written in brackets, so very, very helpfully already factorized for me. Again, I'm not adding or, well, I am adding or subtracting things, but they're only in the brackets. So if I can divide through by everything in the bracket, that is going to work out well. Just to help me like I did before, instead of writing x plus 2 squared, I'm going to write x plus 2 times x plus 2. And the reason why I'm doing that is because it'll help me to see how it's cancelling out with these terms at the bottom. So I can divide the numerator and denominator by x here. I can divide the numerator and denominator by x squared. So I'd be left on my numerator with the other, sorry, not by x squared, by x plus 2. So I've divided the numerator and denominator by x, the numerator and denominator by x plus 2, which leaves me with the other lot of x plus 2 I had, because remember I started off with x plus 2 squared, and that x minus 4. What does it leave me on the denominator? If I've divided x, bracket x plus 2, by itself, I get left with 1. Okay, don't be fooled into thinking that should be 0, because I've got nothing left there. I've divided them by themselves. So same as if I have 5 divided by 5, I get 1. 37 divided by 37 is 1. X plus 2 divided by x multiplied by x plus 2 is 1. So I don't need to write out that division by 1 there. I've just got x plus 2, x minus 4. And that's simplified. Okay, it didn't even end up as a fraction. Okay, last example. So the difference between this example here and this one is here I was given factorized expressions. Here I've not been given them. So I have to factorize them myself. And this is where quite often the questions can be really useful, because if you're told, if you're given a question, simplify this algebraic fraction, you know that it's going to simplify. If it says, can you simplify, that's maybe a little bit trickier. But it telling us to simplify this is a really, really useful step here, and we'll see why in a moment. The first thing I want to do is try and factorize this. It's got an x squared term, an x term, and a constant term, so it is a quadratic that I need to have 2 brackets for. Okay, we've used the grid method before for factorizing these, so let's try and use the same again. I've got x squared minus 6. To get x squared, I need x and x. Now I need to think about how I'm going to get that minus 6. So to get 6, I could use 1 and 6 or 3 and 2. But I want these 2 terms, these are going to be my x terms, to give me minus 1. So I need a difference of 1. So I need them to be 3 and 2. So that would be 2x, that would be 3x. Well, that doesn't quite work yet, because 3 times 2 gives me 6, not negative 6. One of these needs to be negative. To give me minus x, I need the 3 to be negative. So 2x minus 3x is minus 1, lot of x. So it's that 3 that needs to be negative. So my factorized form is x minus 3 and x plus 2. Okay, and why is that useful for the denominator? Well, I already know that one of my brackets here is going to be either x minus 3 or x plus 2, because if it isn't, I can't simplify. I don't know which one of those it is, but it is going to help me in maybe guessing at some of the terms that I might have if I'm unsure. or in checking my work. I've got x squared plus 2x plus 4, so that wants to be... Okay, I've made a typing mistake on this one as well. That should be plus 4x. Okay, so sorry if you paused the video, tried this and thought that didn't work out. I might try and see if I can correct that later, but I'm still getting used to all this technology. So I want x and x here to get this 4. I could have, so how can I make 4? By 1 and 4 or 2 and 2. To get this 4x, I need 2 and 2. And this time, because everything's positive, I don't need to bother about any negative signs. That would give me x squared plus 4x plus 4, which now I've made that correction, we know is what I wanted. So this denominator would be x plus 2, x plus 2. So when I cancel this out now, I can see I can divide my numerator and denominator by x plus 2, and I get x minus 3 over x plus 2. And that is how I would simplify algebraic fractions. Okay, try some of the questions on the worksheet that I've put on the Google Classroom. Do let me know how you get on.